we're taking a look at stretching and shrinking. Use the following diagrams of floor plans of a tree house. I always wish I had a tree house when I was a kid. It'd be so cool. Before and after the reduction and enlargement by a copier to answer exercises 1 through 8. So, the original tree house floor plan, 2 inches, 1 inch, and obviously that's going to be 2 inches. I'm assuming that our tree only produces branches that are squares. My enlarged tree plan, same basic idea, 4, 2, and I got my tree branches. And then my reduced one, 1 inch, half an inch, and I notice how all of the tree branches are happening in the same location. So, what is the scale factor from the original design to the enlarged design? And you'll remember that scale factor is a number that you multiply corresponding side lengths by to get the side length of a new figure. So the question is, what do I multiply 2 by to get 4? Now, obviously, you're going to say it's 2, the scale factor is 2, and I agree, it is 2. However, I would like to remind you that to find the scale factor, scale factor is going to be a ratio. When I say ratio, you think fraction. Ratio, fraction, ratio, fraction, ratio, fraction, fraction, ratio. You get the idea, right? So, this is my original figure, right? So, this is going to be my image. In other words, I am starting at this figure and finishing in this figure. So my scale factor can be made by making the ratio of my image side length over my original starting side length. 4 divided by 2 is 2. So my scale factor is just 2 from my original to my enlarged. Now I'm going to go out on a limb and I'm going to guess that they're going to ask us a bunch of other scale factor problems, right? So circle the answer that tells how the area of the enlarged 3. Maybe we should start with 2. Okay, circle the answer. This is a multiple guess question. Circle the answer that tells how the perimeter of the enlarged figure compares to the perimeter of the original. Well, so if the scale factor is 2, that means that each side length is multiplied by 2. Therefore, this side is twice as long, this side is twice as long, twice as long, twice as long. That means each side will be twice as long, therefore the perimeter will also be twice as long as the original. If you needed to really explain it, you could have found the actual perimeter, so that's going to be a perimeter of 12. This has a perimeter of 3. 3 times 2 is 6. And notice that 6 times 2 is 12. Circle the answer, all right. That compares the areas. Now, this is a little tricky. First, you will hopefully remember we talked a ton about the area being the scale factor squared times bigger than the original area. So if the scale factor is 2, that means the area is 4 times bigger. And that makes sense because, look at this. Here's my original. Here's my enlarged figure. But my enlarged area is actually 2 times 2, right? This area is my original, 1, times 2. 2. 2 times 2 is 2 squared, which is 4 times bigger. So therefore, it has to be D. What copier size factor was used to, okay, well, 2 is equal to 200%. What is the scale factor from the original to the reduced? Now that's a little trickier. So I'm going to draw them out. So the original, 1, 2, and now we're going to the mini 1.5. And remember that scale factor is equal to that whole image over original. And so let's take corresponding side lengths. So my image has a side length of 1, and the corresponding side length to 1 is 2, therefore it's 1/2. And you will remember that going scale factor is directionally dependent, and if you're going from small to big or big to small, and the scale factors going big to small and small to big are related, they are reciprocals. The reciprocal of 2 is 1/2. Turn the page. Here we go. Okay. Circle the answer that tells you how the area of the original compares to, well, we talked about the scale factor squared times the area, right? Well, if the scale factor is 1/2, the scale factor squared is going to be 1/4. So the area will be reduced by 1/4. And finally, obviously, 1/2 is equal to 50%. All right, I will continue on the next couple pages in another video.